Hi, I'm Tammy and I do math for coffee. Today we are talking about inscribed angles. By the time we're done, you're going to be able to do a lot of different kinds of problems, including some that have a little bit of algebra with them. First off, let's talk about some definitions real quick. So we have a circle, and you may have already talked about this kind of an angle. This is called a central angle. It starts from the center of the circle and goes out to the circle. This is an inscribed angle. One of the things you can tell right away is that the inscribed angle is smaller than the central angle. I'll show you that in a sec. But the reason they're related is because they both go to the same points on the circle. This is called the intercepted arc. Because they share that arc, the size of the central angle and the size of the inscribed angle are related. So let me show you how that works right now. Here we popped over to the program that I use for demonstrations because I can move things around and you can see measurements change. We have a central angle of 100 degrees up here, and you may have already learned that central angles and intercepted arc measures are equal. Remember, the arc measure is talking about how this thing is bending. It's not the length. It's just it has a 100-degree bend. Now, if I grab this point and pull it back, I am creating an inscribed angle. The intercepted arc is 100 degrees and this is 50. Now, I could have put that anywhere I wanted as long as I stayed on the circle. If I took this thing off the circle, it changes. But if I stay on the circle, it's still 50 degrees. Now, to see that with the central angle already on there, this is how they're related. The central angle is going to equal the arc measurement, and the inscribed angle is going to be half of the arc measurement. For the first example, you might get a diagram that looks a little complicated. It may not look really simple, so you have to learn how to read it. Well, first off, they want you to find the measure of arc BC. Well, you have to think about those 2 points, B and C. How are they connecting back? And you can see they're connecting back to D. And so we have an inscribed angle of 71 degrees that's going out to arc BC. We figured out already just from the last demonstration that the inscribed angle is going to be half as big as the arc, which means we need to take 71 and double it. And our answer is 142 degrees. That is the measurement of the arc from B to C. You are looking for the arc that goes from A to B or B down to A, this thing right here. And we have a lot of lines on here, but we only have one angle. Right now we have enough information with the 57. So we will do the same thing we just did and then double it. So the arc measure is 114 degrees. This problem will trip people up because it doesn't seem like you have enough information. It's asking us to find angle GBD, which is right down here in the corner at B. And the only thing they're telling us is that the arc measure of B to D is 70 degrees. In geometry, you can assume that if you have a line connecting 2 points on a circle that goes through the center, then that line is a diameter. And a diameter cuts a circle in half. So we do know that this arc that goes around the circle from B to G is a semicircle, and that is 180 degrees. We already know that part of it is 70 degrees, so let's subtract that. And so the arc from D to G is 110 degrees. That's not the answer because we have to go back to the angle. Well, the arc is always twice as big as the angle, so we just need to divide 110 in half. And it is 55 degrees. And that's our final answer. We have two angles that have some algebra stuff on them. Well, what do we know about two angles? Nothing. Let's go back to the computer program, and I'm going to show you something that'll help this problem make some sense. Now we have a second angle. Now, both of these are going out to the same arc, which is 100 degrees. So these two are equal. The 6x minus 7 angle is going to the points B and D, and the 5x plus 4 angle is also going to the points B and D, which means they are both intercepting the same arc. That means they have to be equal to each other. So let's set up our algebra. 6x minus 7 equals 5x plus 4. Now we start doing some algebra and just subtract 5x from both sides. We end up with x minus 7 equals 4. Add 7 to both sides. x equals 11. For this one, we are asked to find angle DAB, and the only thing they're telling us is that A is 17x plus 4. But we also have something for the arc measurement, which is 36x. It would be really tempting to set these two equal to each other, but they're not, right? The 36x is twice as big as the 17x plus 4. There's a couple ways to set this up. I don't know which way is going to make sense to your brain. I'll show you both. The first way is that I'm going to take the 17x plus 4 and set it equal to the 36x, but split in half. So I'm going to take that times 1/2. 17x plus 4 equals 18x. And we do some algebra. And we solve for x. Be real careful. I mean, I've even done this too, where you solve for x and you're like, yay, I'm done. And you're not, because this is one of those plug them in problems. I want to know what the actual angle is. Put that into the expression 17x plus 4, and we end up with 72 degrees. Now I'm going to do this problem again. We already know the answer is supposed to be 72 degrees. We know that the relationship is that the 36x is twice as big. So to set these equal to each other, another person might take the 17x plus 4 and multiply it times 2 and then set that to the 36x. So it's your choice. You can either multiply the small one by 2 or split the big one in half. We run through the algebra again. The numbers are just a little bit different, but we're still going to get the x equals 4, and you would still plug it in to get the 72. This type of problem is also a little bit tricky. The line that's going through V is called a tangent line. It touches the circle at only one point. There's another line taking off from V to W. That is still an inscribed angle. They're asking us to find the arc measure for the other part of the circle. There's more than one way to do this problem. I can look at it right now and see that somebody might want to try to find the angle on the other side of 60, but I'm going to work with the 60. I know that this arc that's associated with the inscribed angle of 60 is going to be 120. So then I'm going to take the 120 and subtract it from the 360, and that's going to tell me that the rest of the circle is 240 degrees. That's the arc measure. Hey, if you haven't already, I would love for you to subscribe to the channel and like the video if this was helpful at all. And check out the geometry playlist so you can see what else I've got up there for you. Thanks for watching. Bye.